Okay, so we're working through examples of some basic common experiments that you'll see in chapter 6, 7, and 8. The last example was on flipping a fair coin. Right? This example is on rolling two fair distinguishable, spit it out, dice. Alright, now our dice will always be distinguishable. There is a difference, and the book talks about it a little bit. It says there, it explains the difference between distinguishable and not distinguishable. Ours will always be distinguishable, and what that means is we'll always be able to tell the difference between the two dice. Either the two dice will be colored differently, and that's actually the example I chose to look at. I got one dice colored red and one dice colored white, so I can tell the difference between the two dice. Or we'll roll them at different times. I'll have my first roll paired with my second roll. Alright, just like with flipping a coin, I had two tosses, and those were two different events. Well, rolling two dice would be two different events. I have my first roll paired with my second roll. Alright, and so ours will always be that case. So the set I decided to look at are color. Alright, so I have one red dice paired with one white dice. One fair, meaning they're six-sided dice. They're typical normal dice, just one's red and one's white. I'm going to roll them together, and I want to know, well, how many outcomes are there total? What are they? And how many? Right, I'm going to use a table to help me list them. Before I list them, and it is going to be important to be able to list the set. It's the best way to find subsets, which we are going to practice in this example. Right, I'm going to count them using this is a Cartesian product rule. Number in my universal set. Well, I've got the number from the red dice paired with the number from the white dice. Right, I've got my elements, whatever can happen on the red dice, all of the elements from the red dice, and I'm going to pair it with all of the elements from the white dice, all of the different things that can happen on the white dice. Well, the fair dice, meaning the red dice can roll 1 through 6, and the white dice can roll a 1 through 6. And so there are 6 possibilities paired with the red, paired with 6 possibilities with the white. And so total number of outcomes is 6 times 6, which is 36 total outcomes. And that's always the case when we roll a pair of distinguishable dice. There's always 36 total outcomes. Alright, now I'm going to list them. And it's important that we can list them because we're going to want to find subsets of this, groups of sets. The best way to do it is to have a list of it. Alright, I'm going to use a table to help me out with that. So I'm going to use a table. Alright, across the side are going to be the red dice number. So the red dice has the numbers 1 through 6. And then across the top will be the white dice options, which are also the numbers 1 through 6, but they're the different 1 through 6 because they rolled on the white dice. Alright, now I'm going to pair them together. So I'm going to pair the red dice with everything from the white dice. Alright, so my red dice rolls a 1. Well, I can pair it with the numbers on the white dice. So I can pair it with a 1, 1, a 1, 2, a 1, 3, a 1, 4, a 1, 5, and a 1, 6. And there are all of the outcomes where the red dice was rolled 1, and the white dice rolled numbers 1 through 2. And they do the same thing with 2. Alright, red dice rolls a 2, and pair it with all the numbers on the white dice. Alright, and so on. So again, this is going to be a set that you're going to want to make sure you familiarize yourself with. We'll be using it over and over again in this chapter, in the next chapter, chapter 7 and 8. You'll see a couple of examples on your first quiz from here, first test from here. And on your second and your third test, we'll have dice examples. And the final exam usually has a handful of dice examples as well. Getting a little sloppy. There are the 36, again, they're a little sloppy there at the end, but there are the 36 possible outcomes when I roll 2 fair distinguishable dice, right? I can roll a red 1 paired with any of the colors from the white, or a red 5, I can roll 5 and all the numbers on the white, and so on. Alright, and so there is my 36 total outcomes. There's my universal set, my big set. Now we're going to look at subsets of this. Alright, so the second part of this example is the same experiment, so that's what we found in the previous example. Now I rewrote it so it's a little neater here instead of using my messy set here, although hopefully you wrote it out and then can read yours. I did write it a little neater here so that you can see it a little better, but it's the same set, it's just written a little neater. I typed it out. Alright, so this is still the same universal set, same 36 total outcomes. Alright, now we're going to look at subsets. Alright, so we want to find subsets of this. Alright, so the first subset, let E, alright, so E is the subset where the sum of the dice is 6. Alright, so I want all of my outcomes, all of the 36 outcomes, where the numbers paired together add up to 6. That's what it means. Alright, so I want to count how many ways does that happen. And I'm going to use a highlighter. This is where having colored pencils or a highlighter can be helpful if you're drawing out the set, just to circle stuff and to write things down. It's just helpful to do that. Alright, so I'm going to use a highlighter. I'm going to use a yellow highlighter to highlight all of those where I've got a sum of 6. Alright, what's nice about this set is the diagonals actually do the sums. If you look at here, the first sum would be a 1 plus 1, which is 2. Next set is a 2, 1, which is 3. Then 4, then 5, and then there's my sum of 6. So these diagonal here are my sum of 6. So highlighted there in yellow are all of the outcomes when I roll a dice that give me out a sum of 6. Nothing else on there will give me out a sum of 6. They're all either bigger than that or smaller than that. And so there are 5 outcomes where I get a sum of 6. Alright, the next subset. So I'm going to read it first. I'm going to go down here and read it. Alright, so set F is the subset for which at least one die shows an even number. And this term at least is going to come, you're going to hopefully become very familiar with it. We use the term in probability and counting at least and at most quite often. Alright, at least means one of the dice shows an even number or more, right? Which would be both of the dice show an even number. Alright, so one die or both dice have an even number. Alright, that's what it's talking about, that at least one even number. Alright, so the number in set F is what we're looking for. And this is one of those cases where it's easier to find the complement. Alright, so I'm going to write what the complement is up here, not F. Alright, so not F would mean the opposite of getting at least one even number. Well, that would be no even numbers. Or a better way to word that is both numbers are odd. Both numbers on the dice are odd. Right, both numbers showing on the dice are odd. That's the easier set to count. So, and actually we need it anyway later on. We'll be finding that set compared with another set. Right, so, number not in F, both of my dice values are odd. Right, I'm going to circle it in red. So I'm going to go through and circle all of the outcomes where both of the numbers are odd. Alright, both numbers are odd. 1, 1, both are odd. 1, 3, 1, 5, 3, 1, 3, 3. Alright, and that's it. Those 9 outcomes that I've got circled there in red are all of the outcomes where both numbers showing are odd, and there are 9 of them. Alright, so if there are 9 where both numbers are odd, which is the opposite of what I'm looking for in F, right? F wants at least one even number. Well, the complement would be, well, I take the total, which is 36, subtract away the 9 I don't want, where I've got both of them are odd numbers, and I should be left over with the set I'm looking for. Alright, so 36 minus 9 is 27. So there should be 27. If you went through and counted, there should be 27 out of my 36 that have at least one or two even numbers, right? If you look at all of these that are not circled in red, there's at least one even number in all of them. Some of them have two even numbers, right? Like 4, 6, and 6, 6. But all of them have at least one even number in them, right? And if you went through and you counted, there would be 27 of those. Alright, so far those are the sets that we're counting. Number in E is 5. Number in F was 27. And then the last one of this example, or this part of this example, is set G. Set G is the set of outcomes where there's that term at least again. One die show a 5 or greater. Right, remember, at least one meaning one or more, which means one or both dice. So 1 or both show a number 5 or greater. Well, the only number bigger than 5 on a dice is 6. Alright, so I want all of the outcomes where I've rolled a 5 or a 6. And I could roll 5 on a 6 on both dice. Alright, that's what I'm looking for. So I rolled a 5 or a 6. So I'm going to go back up to my set. That's my number in G I'm going to write down. And I'm going to highlight all of those that have a 5 or 6 in it. Well, that would be my last rows and my last columns, right? All of these have a 6 in it. All of these had, the red dice had a 5 in it. And then the last row and column are the white dice have a 5 and 6. Alright, so all of those that I've highlighted in blue. Alright, so all the ones highlighted in blue have a 5 or 6 in them. Some of them have both, right? These 4 here have both a 5 and a 6. But all of them have at least one roll came out 5 or 6. And if you count them, there should be 20 there. Alright, 20, so it's for probability, which is eventually what we're going to do. There are 20 chances out of 36 where I'll roll a 5 or a 6. At least one 5 or 6. Alright, so 20. Alright, the last part. Alright, this is combining this counting subsets with our union, intersection, and complement rules. It's kind of combining everything that we've learned so far with rolling dice along with our union, intersection, and complement rule. Alright, we still want to count. We want to find the number of elements in these where I've grouped my set together either using the words and, or not. Alright, so the first example, we want the number in set E and, right, that's the symbol and, in set F. Well, and is the overlap, so they have to have both things be true. Right? E was, we have to have a sum of 6, and F was having at least one number. So you have to have a sum of 6 and at least one even number. Alright, so I want all of the outcomes where both of those things are true. So overlap between E and set F. Alright, so set E, if you remember, was this yellow one I highlighted, and that's really all I need to look. I need to look in this set E. Are there any outcomes where I get at least one even number? Well, there are 2 outcomes where I get at least one even number. Right? 4, 2, and 2, 4. Alright, so the answer is 2. There are 2 outcomes where I have a sum of 6 and have at least one even number. Right, so the answer to this one is 2. Alright, the next example. Remember, that's not, so number not in F, which we actually found, or it can come from set G. Or is the one you always have to be a little careful of. Alright, so not in F. So remember, not in F was not having an even number, so both are odd numbers. Or can come from set G, which has at least one 6, or 5 in the outcome. Alright, so both numbers are odd, or I get at least 1, 5, or 6 in my outcome. Now, the or is the one you have to be careful. Remember, or is all inclusive. I get to include everybody from the first group with everybody in the second group, but if they have overlap, I can't count that overlap twice. So I'm actually going to use my rule. Remember, the union rule is the number in my first set, so the number not an F, plus the number in my second set, which is the number in G, minus anybody they might have shared, the number not an F and in G, who was counted twice. Alright, so I'm going to erase this verbal description here so I have a little more room to work, so give me a second. Alright, now I'm going to list down my numbers. Alright, so number not an F, if you remember, was 9. There were 9 elements not an F. The number in G, remember, was 20. There are 20 elements in G. And then I just have to figure out, well, did I count anybody twice? If I did, I need to make sure I subtract that. So I'm going to go back up to my picture. And I'm going to double check that my numbers are right. And they were. Not an F, there were 9 of them. In G, there were 20 of them. Alright, so remember, G is the blue set I've got highlighted here. Not F were the circles of red. And I look to see if there's any overlap. And there is. There are these 5 that have circled red and are showing up in my blue set. And so they got counted twice, right? Those 5 were counted in the 9 that were not F, and they were counted again in the 20 in G. Alright, so I've got to make sure I subtract those 5 because they were counted twice. Alright, so I've got 9 plus 20 minus 5, and so there are 24 outcomes that are not in set F, or they show up in set G. Alright, now, there is an alternative to this. Now, a good rule of thumb is always write out the rule, right? So you don't accidentally count anybody more than once. You could have figured out 24, though, without the rule, and so I'm going to kind of talk about that before I get to the last case. Right, if you go back up here and you look at, I'm looking at everything that's in set G or not an F. Well, I could count everything in G, right, which is 20, and then include anybody not an F that hasn't already been counted again, right, which would be these 4 that are not an F, that are also not showing up in G. And so I'd count these 20 in the blue and these 4 outside here in the red, and I'd get 24 again that way. Again, that's an alternative to using the rule, but always a good rule of thumb to use it just in case, so you don't count anybody twice, right? There are 24 elements, not 29. Alright, the last example for this set. Alright, I want the number, remember the prime out here means not, the number not from the group E or G. Alright, so E or G, I've got to remember what those were. So, not from the set E, so not from the set where I have a sum of 6, or G was having at least one number 5 or 6. So basically I'm throwing those out. If you have a sum of 6, you get thrown away. If you have a 5 or a 6, you get thrown away. And if there were overlap, they get thrown away too. So I'm going to just go back to my picture and basically cross out set E and G. Alright, I don't want anybody from set E or G. So I want nobody from set E, so I cross them out, and nobody from my set G. Alright, so I'm going to cross them out. Everybody that's not crossed out is what I'm looking for. Alright, so these 3 in here I want to keep. They're not in E or G. And then this set above here are not in E or G. And then I just have to make sure I carefully count. 10 plus 3, so 13. So there should be 13 elements that are not in E or G. 13. Alright, and then the last one's for you to do on your own. Alright, we rolled 2 distinguishable dice. How many different outcomes have a sum less than 8? Alright, so that's for you to do on your own, and again, I'll post the answer to this later on. Remember, sum less than 8, meaning I want a sum 7, 6, 5, 4, 3, 2. Right? I don't want to include 8. It's less than 8. Alright, so all of the sums that are less than 8. Alright, I'll leave that for you to do. Make sure you look this over and understand it. Like I said, you'll be sick of dice problems. because we'll be doing quite a few of them. So make sure you've got dice problems down. Alright, we'll stop there. The next example is going to be a standard deck of cards example, and so that's the next example. Next set of notes.